3-4, the real number system. Today we're going to identify and classify numbers in the real number system. Big one here today is irrational number here. An irrational number is a number that can't be written as a fraction. As a decimal, it never stops or repeats. It goes on forever. A real number is a rational and an irrational number. So what's going to help us out here is this little diagram that we have. You can see that real numbers contain rational, which we've talked about, and irrational numbers. Irrational numbers are something new that we'll talk about today. So rational and irrational numbers are real numbers. Real numbers contain integers. Real numbers also contain whole numbers. Integers contain the whole numbers. So that's kind of how our little diagram works here. A couple other vocabulary terms here. Real numbers, well, we just talked about it. Real numbers contain rational and irrational numbers in the real number system. Irrational numbers, this is what's new today. And again, you already have this down. But they're numbers that can't be written as a fraction. As a decimal, they go on forever and never repeat. That's already listed on your piece of paper. Something else you might want to just write down. I know we've covered rational numbers, but it's not a bad idea to have it down. And those are rational numbers. Rational numbers are numbers that can be written as a fraction. And as a decimal, they would terminate or repeat. Integers, we covered back in Unit 1. Integers are positive, negative whole numbers. So they're positive, negative whole numbers. And last would be whole numbers. Whole numbers are numbers like 0, 1, 2, 3, 4. They're whole numbers. The biggest thing is they do not contain negative numbers like integers would. So our first example here says name all the set of numbers to which 0.090909 belongs. This number here has a repeating pattern. Okay, we know that's part of the real number system, but we need to determine from that table there, if you look back at your table here, does it belong with the real numbers, or does it belong with irrational numbers? So when we come back here, we need to determine, is it rational or irrational? Well, 0.090909 has a repeating pattern. If it repeats, this would be a rational number. So rational, we could write this as a fraction. Now you need to determine, if you look back at that table still, is it an integer? Well, it's not an integer because this is not a whole number. So it's not an integer, and it wouldn't be a whole number. So the only number set that we would write down is rational. This is a rational number. Next example, name all the set of numbers to which square root 25 belongs. When dealing with square root, I'd go ahead and find it. So square root 25. Well, we know that the square root of 25 is 5. 5 is a rational number. You can write this as a fraction. Not only is it rational, it is also an integer. It is a positive whole number. And it also is a whole number because it is positive. So these three are what we'd write down. That 5 belongs to all those set of numbers. Example 3. Name all the sets of numbers to which negative square root 12 belongs. Well, first thing I would do is figure out the negative square root 12. Figure that out. Well, we know that we're not going to get a whole number here. So it is an approximately, and this is when you put that on your calculator, we get about negative 3.464101615. And that's all the numbers that it displays on your calculator screen, because it displays 9, 10 digits. Well, if you look up here, nothing is repeating. It's not stopping. So if it doesn't repeat and it doesn't terminate, this is an irrational number. We could not write this as a fraction. Example 4. Today when we estimate here on example 4, I'm going to actually let you use your calculator for today for your estimation. The biggest thing is I'm going to look at is for the rounding piece. So I want to make sure that we're rounding to the nearest tenth. So we're going to round square root 8 and negative square root 2. Go ahead, type that in on your calculator, and you would find out that the square root of 8 is approximately 2.8. That's rounded to the nearest tenth. Negative square root 2 is approximately negative 1.4, rounded to the nearest tenth. Now we need to go ahead and graph these on a number line. So here's your number line. We have 0, 1, 2, 3. When we graph the square root of 8, we see that the square root of 8 is 2.8. So 2.8 would be approximately right in there. And then I'm going to go ahead and put square root 8. And then we need to graph negative 1.4. Negative 1.4, well, here's the halfway point, slightly below that, so we'd say negative 1.4 is about right there, so that's where I put my negative square root 2. Same example in 5. I want you to go ahead and pause the video here, work through it just like we did in example number 4, and we'll pick up from there. After we've done our computation, the square root of 3 is about 1.7 rounded to the nearest tenth. Negative square root 6 is approximately negative 2.4 rounded to the nearest tenth. Go ahead and plot them on the number line here. Square root 3 would approximately be right in here, and that would be 1.7-ish. So square root 3 belongs there. Negative square root 6 is negative 2.4. Well, negative 2.4 would be down here slightly below negative 2.5. And there it is graphed on our number line. Example 6, it says replace with less than or greater than or equal to make 3 7/8 and square root 15 a true statement. Now in order to do this, I would go ahead and write this down, 3 7/8, and we have square root of 15. I would go ahead and figure out what those would be as decimals to make things easier to compare. 3 square root 8 is 3.875, and square root 15 is 3.87298 about, and probably continues on from there. Now if you look at this, we have 3.875. Well, they both begin with 3. So they both look equal. Look at the next point after the decimal point. They both have an 8. Both have a 7. Here it is, 5 and a 2. Okay, these are both positive numbers. If they're both positive number, this would be the greater one, so we need to go ahead and throw our sign. So we'd say 3 7/8 is greater than the square root of 15. 7, use our same problem solving technique here. We have 3.2 repeating. Notice that is a decimal. 3.2 repeating, which would be 3.2222. Continues on. Figure out what is the square root of 10.4. Well, the square root of 10.4 is approximately 3.2249, and it would continue on from there. So we look at it again. Look at our decimals. We have a 3, a 2. Everything's looking the same. They're both positive. 2, and then we have a 2 and a 4. So being both positive, we know that the square root of 10.4 would be greater than 3.2 repeating. Last problem here, it says baseball, the time in seconds that it takes an object to fall d feet is 0.25 square root d. How many seconds would it take for a baseball that is hit 250 feet straight up in the air to fall from its highest point to the ground? So we need to go ahead and use our equation here. The equation that we have is right there. We have 0.25 square root d. Actually, it's an expression. But we need to go ahead and substitute in what we know. Well, this is for an object to fall d feet. Well, we know that the ball was hit 250 feet straight up in the air. So once it reaches that maximum point of 250 feet, it begins to descend. So we have square root 250. 250 is that height. Go ahead and figure out what this would be. Well, we get 0.25. The square root of 250 is approximately, and I just rounded this to the nearest tenth again, 15.8. Multiply this together, and approximately it would take, if a ball was hit up to 250 feet in the air, for that to fall down to the ground would take approximately 3.95 seconds. This will conclude 3-4, the real number system.